let's do something. All right, first thing I want to do real quick, I said this would be fast. I want to do a quick lecture on 3.1. Okay, there's not a handout that comes with it, so you can sit and watch because it's pretty simple. Or if you need to take a picture at the end of it, please do. And then we got other things. Someone flip the lights off for us, please. Or if you can just have a sheet of paper out, that would be fine as well. Scrap paper is fine. So 3.1 notes pretty fast. Okay? I have 2 lines. They're not necessarily parallel to each other. Agree? Yeah. Can everyone see the green okay? Yeah. Any complaints? All right, the next one we'll do in a different color. We'll do it, orange. Oh, sorry. All right, so if you have 2 lines cut by another line, the other line, in this case the other line is orange, is called a transversal. With me still? So if 2 lines are cut by another line, that other line is called a transversal. So, transversal. Okay? So some great things that do take place. Let's just start naming these angles. I have angle 1, 2, 3, 4, 5, 6, 7, 8. Still with me? Think okay? All right, so there's some definite things that you can conclude off of this. You can say that angle 1 and angle 4 are congruent. You can say angle 2 and angle 3 are congruent. You can say angle 5 and angle 8 are congruent, and you can say that angle 6 is congruent to angle 7. Why can I say all of that? What kind of angles are they?
Vertical.
They're vertical angles. Okay? The vertical angles take place there. Okay, that's something we definitely want to trust. Other things that we could state about this is we could say that angle 1 plus angle 2 equals 180. These were all actually equal to 180. I just lost 7 and 8. And angle 5, angle 7. Those are all equal to 180 degrees for what reason? Linear pair, which linear pair could also be called supplementary, but supplementary can't be called a linear pair all the time. Make sense?
What?
Good? All right, so those are some definite things that if you were to be given this diagram, should be go-tos right away. Okay? We don't have enough information to necessarily say the 2 green lines are parallel. I made them not look parallel for a reason, because they don't have to be. But then we're going to start naming some other angles. So angle 1 and angle 5. Angle 2, angle 6. Angle 4 and angle 8. And angle 3 and angle 7. Notice I have 1 tick, 2 tick, 3 tick, 4 tick. Still with me? Yep. So these are called corresponding angles. So corresponding angles happen to fall into the same location. So angle 1 and angle 5 are corresponding angles because they're kind of in the upper left part of the graphs. Make sense? And angle 2 and angle 6 are corresponding angles because they're in like the upper right portion of their graph. And angle 4 and angle 8 are corresponding angles because they are like in the lower right. And then angle 3 and angle 7 are corresponding because they're in the lower left. Yeah. I didn't hit you when I went up. Yeah, I'm just kind of going off the cusp. Does that make sense? So those are called corresponding angles. Okay? Sometimes corresponding angles could be equal, but at this point, we just know they're called corresponding. Cool? Everyone have a visual of that? Oh, my camera wasn't centered. Okay? All right, so can I get rid of the corresponding angles for right now? Can I do that? We good? Go bye-bye? Undo. All right, so those are corresponding angles. Next thing we're going to do is, we'll do this in blue. Angle 1 and angle 8 are alternate exterior angles. Angle 2 and angle 7 are alternate exterior angles as well. They alternate on either side of the transversal. They are on the exterior of our two original lines. So these are called alternate exterior angles. Yeah.
And if the two green lines are parallel, you could say the same for like 6 and 3 and 4 and 5, right?
Not for alternate interior or exterior. Okay, so that's alternate interior. And so if those are alternate interior, what do you think 3 and 6 are and 4 and 5? Alternate interior because they're on the inside of the green line. So I have alternate interior angles. Cool. Okay, so alternate interior inside of the green lines, flip-flops of the flip-flops over the transversal. Alternate exterior are alternating on either side of the transversal, and they are on the outside of the parallel lines. All right, let's see. I'm going to run out of some colors here. I need more colors. Custom colors. Oh, dude. Oh, okay. Oh yeah, that's kind of a darkish blue. All right, ready for this? Three and 5, or angle 4 and 6, are called same side interior angles. Not mine. So same side interior angles, meaning they're on the same side of the transversal. They're on the inside of our green lines, which are just two arbitrary lines that are drawn that aren't necessarily parallel. So we talked same side interior, alternate exterior. We already said vertical angles are up there. We have linear pair or supplementary angles. Corresponding angles were our very first thing we talked about. And that is all I have to say. Consecutive interior.
What?
Same side interior, same thing as consecutive interior. Thank you. Same side, so consecutive interior. So consecutive or same side interior, same thing. Okay? Yeah.
Is there anything like do same side exterior angles exist?
They probably do. They just haven't named them. Okay. All right. So worksheet 3.1. When did I say that one will be due? Monday. Okay. So 3.1 will be due Monday worksheet. Okay. And then there was another one to do as well. All right. Now let's go. That's all I have for 3.1. You should have enough information to run through what that information is pretty easily. Okay. So let's get our, let's talk, is there any that, if I could talk, I'd be a much better person. Is there anything from 2.4a or 2.5 you would like me to go over that I had not gone over yet? Go ahead.
7.
7. 3.5, number 7. Yes. Okay. Ooh, that's a toughie. All right. Ooh, that's kind of a cool color. I like that. Blessing. Blessing.
Blessing the gene.
Blessing the genes.
I'm sorry I called you Japanese.
It doesn't bother me calling me Japanese.
Mr. Thorough,
Yes,
are you a weeb?
What? What am I called? A weeb?
A weeb.
Spell that.
W-E-E-B?
What is that? I don't know what it is.
It's okay.
No, you brought it up. Come on.
No, it's okay.
Come on. Don't be stuck up. Tell me what it
Don't
means.
worry about it. I mean, you can go in Urban Dictionary and look it up.
Dude, think I got an Urban Dictionary with me?
It's all fine.
He's a math teacher.
Man, you're killing me, Smalls.
You already said that
Oh.
before. You-
All right, and I just need to write FG. We want to prove this and HJ. We want to prove that, right? Okay. So they told us that they're telling us that this distance here and this distance here are the same. So we're not really worried about the rest of the shape, I don't think. Okay, so an important thing is maybe this would be good, saying that FH is equal to GH, or GJ, excuse me, definition of congruent. That way it allows us to sub in just in case. And then I think we could go with FG plus GH is equal to FH. And the same reason for number 4, we can say that GH plus HJ is equal to GJ. And that was just segment addition. SAP okay? Now write it all out, dude. All right. So, oh, maybe, no, yes. Yeah, I like this. I think we could do FH. Where does FH? All right, FH, those are equal to each other. So if these are equal to each other, then I could plug this in right here. So I'm going to say step 5, I could go FG plus GH is equal to GJ. What did I just do? Substitution, good. Okay, and then being that this is equal to GJ and this is equal to GJ, then I can go ahead and state that GH plus HJ is equal to FG plus GH. And what would that property be? You got it. Transitive.
Transitive.
Transitive. All right. So if transitive works there, then I can make this move right to here and say that HJ is equal to FG. What happened? What did I do? How did I get rid of?
Subtraction.
Yeah, I got rid of that and that by subtracting. So subtraction. And then my 8th step, I could state that HJ is congruent to FG. G. And that would be definition of congruent.
How did you get front of 6 the transitive?
Transitive property worked by, I have this entire thing, and this entire thing equal to the exact same thing.
Okay.
That's how. Yeah.
Did you just say, so give the given and then just say FG is congruent to HJ because of segment subtraction, kind of like what we did yesterday?
I like that. That might be a good jump. So you want to go to given just and subtract right away? Is that what you're saying?
Yeah, that's just what I did because I just saw.
Because it does. It seems like there was a postulate I think that we hit. It might be on the yellow sheet I think. That talked about the segment subtraction along with segment addition. That might work. What I do like about if you went this far out, you are having it all put together in order to make that jump. So if you truly know that that would work, I guess what you're saying, I think you're correct because one, our diagram makes it obvious, and I like that. So I think that'd be okay to go with as well. Okay. What else? You all right about these? All right. You want me to pick these up now, or do you want to hold on to them until tomorrow during the test?
Now.
Okay. Do you want to turn them in?
Yeah.
I kept talking. If you would like to turn them in now, let's put them. Put them here on this desk, please. And don't trip over my computer cord. Watch out for the computer cord.
You need like a caution sign to put up the board.
Girls have to help me out. What did I just cover the back and the front of the first page and that's it? There was no other? Or did I start doing the proofs? I can't remember.
We didn't do the first step.
I just did the front and the back of the first page and that was it.
I
Good.
think we still have.
Okay. So let's go to the portion. The second page says chapter 2, extra proofs. And we have this segment that's up there. Yeah. And make sure you find that it's true on both. It has to be true on both.
And if it's not, then there's no answer.
Get an answer yet.
Second page.
So chapter 2, extra proof practice. It has a diagram on the upper right hand that looks something like that. Right? No choking. So C is midpoint of AE. That's a given. What?
My work with this had the.
This would have been what I handed out yesterday. And that's a given.
Do we have to put the numbers?
The number 1, the number 2?
Yeah.
For you, no. That makes it easy for me to grade. Just putting a 0 on it.
Okay.
Oh, dude. All right. So, because of this in our diagram, what can we state about that? AC and CE are equal. Let's just stick with the equal if that's okay. So step 3, why is that? Definition of midpoint. Oh, what are we trying to prove? BC. We're trying to prove what? So we're trying to prove this and this are congruent, right? Okay. All right. Now, other things that I would probably go with on here is this might show nicely. Why can I state both of those?
Segment addition.
Segment addition. Okay, and again, is it always necessary? Some of your minds go to a different spot, which is okay. Segment addition postulate works really nicely right there, though. So if I do something like that, I think that they should have bars in both, but they don't. I think we can utilize step 2. And step 3, I think that could work out. So we could state something like this. I'm going to plug in right here. So I'm going to go DE plus BC is equal to CE. Because I also plugged in for this. And that was just substitution. And I can do the same thing with step 5. So I'm going to plug in here CD. Oh, wait, shoot. CD plus DE. DE, oh, we got that. So I'm going to plug in here and here. So I have CD plus GE. AB equals, hang on, AC. Can I do that? And that's again substitution. All right. Oh shoot. Oh, dookie. GC, BC, and CD. Got that there. And oh, you know what? If we set those equal to each other, is that going to work? Can I do that as far as,
Oh, yeah.
that's transitive,
What?
right? Because this and this are the same, so that quantity and that quantity. And then I'm going to subtract what from both sides? Can I subtract AB? Oh shoot, is that what we wanted to say? BC is equal to CD? Dude, we got it. Someone asked yesterday, can I make this leap right here? I think that's okay. Yeah.
Could you have taken like CE, because like CD plus DE equals CE, step 5 and plug that into D plus BC equals CD?
Yeah, I think that would have worked as well. I probably made 2 extra steps. I'm sorry, but I think yeah. Yeah. Go ahead.
Can you explain the
6th
6th step?
step, the substitution here. Okay. So what did we do? We had. Oh, okay. So we did kind of a double substitution here. I took from up above our givens, I put AB and I put it as DE. AB because of that right there. And then I also took, being I knew that AC and CE were the same, then I just switched out AC and put in CE. It was like double substitution that we did. Yeah.
So if I was to use segment subtraction,
That might work as well. Yeah.
should I like do AB plus BC equals AC and then CD plus
So where your segment subtraction would work,
Yeah.
let's say I have this and I have this. equals triangle, I would probably show something like this, or not that. Or some, no, it would actually be this. I'm sorry, I'm getting dumb. So I'd have something like that, and I realize they're just square, triangle, and circle, but something like that is probably what we're looking for in segment subtraction.
So like get to that point and have it be valid, should I use substitution? So like AC minus AB equals BC and
Yeah.
C minus B
Yes.
equals
Yes. Good. Yeah.
Wait, so since 8 is transitive, is that because of the substitution steps before?
Yes, because of the substitution we had done, we were able to then allow this transitive property to work. So we had this whole stuff equal an individual thing, and that individual thing was the same down here, equal to this whole new stuff. Yeah.
How did you probably just answered it, but how did you figure out
Which number are you on?
on number 8,
8.
which equation to use?
Because I was keeping in my mind that I wanted to make sure these were opposite sides of each other. And by me doing that up here, because the BC came down here, and the CD was here, is that it? I knew that, if I had the same thing on the same side, in this case it was AB, that by manipulation and substitution, I was able to get AB on either side, so I don't know if I subtracted it, it would then equal it. So it's a big puzzle is all we're doing. And it's not the most fun puzzle, I get it. The word searches were funny until the teacher realized that diagonal backwards was okay. Do you remember the word search? What the heck is he talking about? All right, we feel okay? Can I go to number 2? We set. Number 2. We have some diagram here. Call that L. Some other line here. That's. I don't really have that called anything. Call that M. And we know that a line that intersects two other lines is called a transversal. That's angle 1. That's angle 3. Angle 2. And I'm just going to circle what we need to get to. I want to show that 2 and 3 are equal. Okay? So 1. 2. Okay, these are all givens. Cool? Alright. So L is parallel. L is perpendicular to P. So that means automatically you have 90s right there. Is that okay? And M is perpendicular to P as well. So I'm just drawing in on this. That's a go-to. Do I need to go and say that this particular angle here and this one and this one and this? No. It's just I'm marking. I know that perpendicular in my mind means this. That means I'm going to create that. Do I know if any of these are perpendicular? I don't know what the heck this line is, so we can't say anything yet. And then we also know that 1, this angle here, and 3, this angle here, happen to be congruent to each other. Okay? All right, so what did I do? Given. I guess I could go ahead and state that angle 1 is equal to 90 degrees. And I could probably also say that angle 2 is equal to 90 at this point. Does that make sense? Why can I state both of those? Definition of? Definition of perpendicular. Is that all right? Oh, you know what we have to do? We have to say this. Definitely have to say that. And then from there, I can state that 7, I could go, what are we trying to prove? 2 and 3. So I'm going to take this and plug it in here. So angle 3 equals 90 degrees. Substitution. And then step 8, I can then say that angle 2 is equal to angle 3. That's transitive. And where are we trying to prove or congruent? Yep. And then last step. And that is definition of congruent. Cool. Good. I like that one. So in the medical class this morning, Dr. Tyler Smith, who is a graduate of Cherry Creek High School, went through something called a differential diagnosis. And what he did is he said, I have this patient, and had a picture of a person who looked like it was a patient, and he went through something called a differential diagnosis. And a differential diagnosis is exactly this type of thinking going through. If someone comes in and says, you know, my chest hurts, and you went right to saying he's having a heart attack, might not diagnose it appropriately. You might be completely right, but there's things you have to go through in order to get there. Okay? When did you realize this happened? When the baseball hit me at 90 miles an hour in the chest. Oh, is it a heart attack? No, there's something else taking place. Okay? When did this start? You know, I woke up last night about 3 o'clock in the morning. It hurt like crazy. I'm a little dizzy. I have a fever. Boom, it goes to something else. It's this type of logical progression of events. Now, are they trying to prove 2 lines are parallel as an ER doc? No. But it's a differential diagnosis with the same type of thought process that goes through. Does differential diagnosis save time of a patient? Yeah. Does it save money? Yeah. Why? Because you're not ordering tests that aren't required. Someone comes in for an ingrown toenail, you don't want to see that they have, a canker sore in their mouth or something. I mean, it's just go through the right events. Yes, I imagine one day things will be like Star Trek, where we could scan an entire person and find all of the missing amount and things. I think that's kind of when you go through the TSA screening at the airport. Here, put your hands up. And they go, woo, woo. I wait to, oh, my blood sugar is this, my pulse is this. I would expect that to give me all of my medical terminology at some point. But all right, back to math. Sorry. Number 3. All right, we have a picture that looks like this, kind of. And then we know the following. Angle 1 is congruent to angle 3. And we want to prove that angle 2 is supplementary to angle 3. Right? That means they're going to add up to give us 90 degrees. Okay, so this is given. I also know things like this. I could state that angle 1 plus angle 2 equals 180. Why? Linear pair, right? If I could do that, then I can go ahead and state that angle 3 plus angle 2 equals 180 degrees. Substitution. And then I could do this. Because of subtraction. And then that's going to allow me, from last chapter, to state this. Done. Yes, I got one done in less than 10 steps. Yeah.
Why do you do that if on step 3 you're already stating that angle 3 plus angle 2 is 180?
because it asks us to show that angle 2 is the supplement of angle 3. And that would have come with the last chapter. Remember when we said you have an angle x and its supplement, so you have x and 180 minus x. That's where we're grabbing that from. Is there another question? Cool. Yeah.
How'd you get for number 3, angle 3?
No, this was substitution because I knew this right here. This allowed me to plug angle 3 into right here to get to the next step. Cool? All right. We have time for probably one last one. Let's take a look. So I have 4, orange, green, or white. 4, orange, green, white. Vote for one, please. We got an orange, green, green, white, white, Big white one.
4.
White one. Alright, this is the white one on the very back page. So my next step would say this. Definition of complementary. Is that right? And then we want to prove that they're perpendicular lines to each other.
Can't you say that angle AXC is 90 degrees?
I'll go with that. I like that, and that would just be the definition of complementary or right angle, something like that would work. And I think that would allow us then to go, yeah, I think we can go right there just because of the diagram. XA, and so they're saying array is perpendicular to XC. So I should have drawn that like this, like that, I guess. And that would be 90-degree angle. I don't know. Definition of congruent, something like that, or complementary. Thank you. Something like that.
Why would it be complementary if that's
Complementary angles are 90. Perpendicular have to be 90.
okay, but that's just perpendicular.
When you say definition of perpendicular,
Okay.
that's what I said.
Yeah.
I like that too. Def perpendicular. We've already defined perpendicular. All right. So done. You can leave it. It could be one single problem. Could be. But like maybe put something outside this way and outside this way to see if they work. But it could be an infinite solution.
Like a 6 and then
All right. So guys and girls. So if you did not turn in worksheet 2.4a and 2.5 today, then bring these tomorrow. Okay? Shh. Also, 2.4b will be due on Monday, right? Then, here's a curveball. I have this huge assignment on Schoology. That'll be due Friday at 11:59 p.m. Tomorrow, Friday. It's
Just submit that at 11:59.
11:59. Someone's gonna be on there at 12:01 going, "What's up with this?" Alright, tomorrow. This should take you 3 minutes. Should take you 3 minutes. 2 of those minutes would be logging onto the computer. Okay? Make sense? Alright, and then also 3.1 is due Monday as well, correct? We good? And then mañana is a test. Tonight is a football game and a band show and Palms show and a cheerleading show and a tailgate party. It could be that. Check negative once it works. Okay.